we want to write the expression for the function for this graph. Now this function clearly has two distinct parts. Okay, we've got this circular portion and then this line. And so this is going to be a piecewise function. Okay, so we've got f of x equals, and then we've got two different definitions here. Now, I'm going to skip what they are and go ahead and just state the domains for each of those portions. Okay, so it looks like between 0 and 2 is our first portion. So if x is between 0 and 2, and then the next portion looks like between 2 and 3. So if x is between 2 and 3. Now, as far as where to put the equals when x equals, you'll notice that for this, x can definitely equal 0. Okay, we've got that point. If it couldn't, we would see kind of an empty hole right there. Okay, but it is connected, so it does equal 0. And then at 2, okay, well, both of these portions touch the same point when x is 2. So actually, either one could be equals and the other one not. Doesn't really matter because they touch. However, sometimes you may have a curve. I'll just sketch one real quick. That looks like this. Okay, where at a value only one curve touches it, it's filled in, and then the other curve has an empty hole there. And so you just put the equals in that case where you have the filled in hole. Okay. Now here it doesn't matter because they're both touching the same point. All right, so now we need to get the equations of these two different parts. So first we've got this circular part. Now the equation of a circle is x squared plus y squared equals r squared. Okay, this is a circle that's centered at the origin with a radius of r. So we can see this would probably, kind of extend and kind of continue around. Okay, it looks like that is centered at the origin and it has a radius of 2. So the equation of the circle, the full circle, is x squared plus y squared equals 2 squared, which is 4. Now we just have this portion from the top, so we're going to go ahead and solve for y. So y squared is equal to 4 minus x squared, and then we can take the square root of it. Now when you take a square root, when you introduce a square root, you have to put in a plus or a minus. Because y could be a negative number, because you square it, it's still going to be the same as if it was a positive and you square it. But when y equals plus or minus, that's two different curves. So y equals positive square root, that's the top half of a circle. And y equals the negative square root, that's the bottom half of the circle. Now we're obviously just looking at the top portion, so we're going to use the positive. So we've got the positive square root of 4 minus x squared. Okay, now we've got this line. We need the equation of that line. And in general, the equation of a line is y minus y naught equals m times x minus x naught. This is point-slope form of a line, where we have the point x naught, y naught, and we've got the slope m. Okay, well, here we've got two different points. We've got lots of different points, but we've got our endpoints here. We've got 2, 0, and we've got 3, 2. So we certainly have a point. We could use either one of these as our point, and we need to know our slope. And slope is rise over run, or y2 minus y1 over x2 minus x1. So we'll take our 2 minus 0 and then divide by 3 minus 2. And that's 2 over 1, which is 2. So now we can plug this all into our equation. I'm going to use this point, 2, 0. So I have y minus 0 equals, and then m, which is 2, and then x minus 2. And now we can simplify this. So y minus 0 is just y. And then multiply the 2 and you get 2 times x. And then 2 times the negative 2, which is minus 4. So that's the equation of this line. So this is the expression that represents this curve here, which we assume starts there and ends there.